Good afternoon. Yeah, we are recording. I couldn't see. So, regarding this whole compactified time thing, and it's like, wait, like, clearly, more than a Planck second has gone by. So, how can the universe be a Planck second? Like, how could time be a Planck second in size? It would clearly, there's eternity. And one of the things is like, compactification is not like, it's not that a line has an end. It's that there is no end. If you see one of my previous things, when you compactify a line, what you do, boom, let's just do it quick. Here's 0. Here's infinity, or highest number, 1 to 10. We're going to compactify it. We just joined them together. Right? This is what we did. We did this. So, and now there's a gradient from 1 to 10, but then all of a sudden there's this moment where 10 and 1 are like the same point. There's an infinitesimal, and infinitesimals are nothing. So, but there's like that weird catastrophic point where they join up. Now, a lot of the time when you see a two-dimensional space rolled up, people use spheres. But a sphere doesn't have the implied closure of that, where when you reach the maximum density pole, let's say one of these poles was minimum density, and we'll make density, how about like that, the straightness of the line or not. Okay, so there we go. And then increasing, and it's like, since we're doing the chirality or whatever we're going to call it, the curliness is the density. You do very high density. So this would be very low density, and this would be very high density, right? But these don't join. And this is why I'm obsessed with this shape Shirley surface in all my other videos, because it's the shape where this connects to this. But the weirdness is that when you do that, then when you're coming off the top, you end up being on the inside of this suddenly. So that's a whole other thing. Let's stick with this compactification. But the thing is, like, there's lots of routes. Like, the fastest way you can go is from here to there. That's minima to maxima in path of least action, which I don't know where that happens. I guess that probably is happening all over the surface of protons and neutrons. That's why they're the highest density, because they're just like, everything's happening like that. But you can also go like this and follow this path, or you could go like this and orbit here for like 10 bazillion rotations, because you still haven't actually gone this way, and this is the path that must be completed. How long you take to complete that path is your business. Oh, actually, I got a boost. I'm going back this way. Okay. Oh, no, I'm going to sit here for a while. Like, oh, I'm going to go like this. The closure just has to happen eventually, because this is a density function of the path. But the path itself can be anywhere on this minima to maxima surface, and anywhere it chooses, any kind of orbital it wants on the surface, and then eventually, everybody, we're all right now falling towards the center of the galaxy. We're all falling towards the sun. The sun is falling towards the center of the galaxy. The galaxy is falling towards the greatest attractor. It's all falling like that. But this is just to trying to help, I think, people understand that compactification doesn't mean that you only have a Planck second at all. It just means there's a constraint about getting from minima to maxima, and that the shortest time you could do that in is a Planck second. And that's why we have the Planck limit. That's why we have the speed of light, because the speed of light is exactly It's like a charge that goes across a whole bed of these things in a way. It's a way of envisioning it, right? And it moves 1 Planck second, 1 Planck length per Planck second, local space-time density, you know? So yes. So I just thought that might help a little bit in terms of conceptualizing for people, because I'm very visual myself. This is one of my problems, is that I'm very visual and I'm not so symbolic. My symbolism always services geometry, but geometry is incredibly informative. A sphere has its so much information is embedded in this shape, and surely surface. Again, the reason I love it is because the cardioid and it, hypnotizing. Anyways, the cardioid and it and the sphere, all it's like, their inherent structures communicate so much information. The cardioid is every single possible tangent angle, 360 degrees of every single possible tangent angle once you do a little rotation thing. It's just amazing. Anyways, peace. Happy solstice still.